So like I said, we start, there's 6 parts and we're going to start with mechanics. Well, does anybody know what mechanics is first? Yeah, you know? Yeah.
Is it has to do with forces and mass and Newton's laws?
Newton's laws, yeah, that's it. Yeah. Well, I suppose even before we start with mechanics, we have to start with units. Okay. There are 3 main units, 3 important units for us. So this is important vocabulary. Length, mass, and time. So there are 3 most important units. There's many units, but they're the 3 most important ones. Okay. Well, that's not even units. I better close that door. It's okay. Would anybody know the difference between units and dimensions? I mean, they're almost the same thing, but there is a bit of a difference.
Hello.
Hey.
Hello. No, it's not true. No,
I think you're on the wrong
001. Sorry.
Idiots. Okay. So does anyone know the difference between units and dimensions?
Yes. Dimensions is
The
what you said. And
Yeah, go ahead.
It's the multiplication of units and less.
You use units to measure the dimension.
That's the closest so far. It's hard to explain, isn't it? But units is used to measure dimensions. So here, none of those have any units. There's no meters, there's no feet, there's no kilogram. They're dimensions, which means they're almost like concepts, you know. In Ireland and in most of the world, what units do we use to measure?
Metric.
Yeah, what's another name for that? You're right, it's metric. There's another name for it. Yeah, for this system of units, meters and kilograms, centimeters. What's the name of it?
I know the other one, it's imperial, but
Yeah.
I forgot the...
You said metric, but that's fine, but there's another name for it. Very good, SI. Yeah. I think everybody here uses SI back home. There's only one place that doesn't use SI. Where's that?
UK or USA.
USA, but UK uses a little bit, but USA then. So just be careful here. These are dimensions, okay? Whereas kilogram, meter, well actually let me keep it the same. Length first, so meter, kilogram, second, these are units. Okay. Okay, so just a little bit of notation here. If, to save time, we don't always write length. So a capital L means length. Capital M means mass. Capital T means time. And again, they're not units, they're dimensions, okay? It's important that you know that for the next part. So just write LMT beside these. Okay, so now, I scroll down. Yep, okay. So it's still part of units and dimensions, but so we'll go with a different color then. So what does dimensional mean? So dimension is the noun. So what do you think dimensional is? If dimension is the noun, what do we think this word is? Any idea? Yeah, it's the adjective. Yeah. So what we're going to look at now, dimensional analysis, that's a way of looking at the equation and seeing what type of units you need. Okay, so for example, okay, let's take a simple example just to give you the idea. I'm sure you all know, well I hope so, the formula for speed. The simple formula, the one you might learn in middle school or elementary school.
S over C.
Yeah, give it to me as a word. Distance divided by time, yeah. And we would like to know what unit we use for speed. Now I know you already know it, but this is just to give you the idea of how it works. So when you want to know the units of something, you put these brackets around it. So we say the units for speed is the same as the units for distance and the units for time. Okay. Distance, is that a length, a mass, or a time? It's a length. And time is a time. So we can say speed has the dimension length per time. So if we were in Ireland and we're using the SI system, we could say it's meters per second. But if we were in the US and we were using the other system, we could use then feet per second. But what's convenient about using dimensions is this doesn't change. This is the same everywhere. It's the units that change depending on the country. Okay, so the units stay the same and the dimension, the units can change, the dimension, that has to stay the same. Okay? Let's do a more difficult one maybe. Or maybe I'll give you one to try actually. Well, do you need to write that down? Or do you have it? You have it? Did you write it down? Oh, no. Don't do this. Week number 1, class number 2. Write everything down. I write down. Okay. Go down, yeah? Okay. So let me give you one to try. Well, actually, before I give you one, let me give you some little rules that might help you. You can only add two things together if they have the same dimension. That makes sense, doesn't it? You couldn't do this. You couldn't add mass plus time. I mean, that doesn't make any sense, okay? So to add them together, they need the same dimension. So this is good. What about if I want to multiply them? Same or different?
Different.
It could be different. Yep, that's right. So that's fine. Dividing, they can be different.
Yeah.
Yeah, that's really it. Well, minus is the same thing as adding, really. Okay, but you can't add different ones. So this one here, no good. Okay, all right. Let me give you another example then. So I'll give a formula that we all know, or maybe we know. U plus AT. Okay. Now, I want the unit for V. That's equal the unit for A plus the unit for AT. Now, I'm allowed to drop this. Why am I allowed to drop this? Why can I do this?
Because A times T is the same as U times
Yeah, give me a simpler reason though. Try to relate it to what I was just saying here.
Oh, because anyways, if you add them, they're the same.
Yeah, if you add these, they have the same units. So it's enough just to look at the first part. You don't need to look at the second part here. So we know that V has the same units as U. Okay? So if you knew that U was speed, then you know that V is also speed. Okay? Right, I'll let you try one for me. And what I'll tell you is U is speed. I'll write it actually. And T is time. So tell me what the units are. But I'd like you to write it out the same way I wrote it out. And you have from earlier what speed is, L over T. Okay? Alright, so write that one down for me. Okay. You got that written down? So what I was picturing you writing down is units for S equals units for UT plus units for, sorry, I keep mixing them around, dimension of a half AT squared. So dimension of S is equal to dimension of UT. I can get rid of that. That's dimension U, dimension T. Okay, U is...
Speed.
What's wrong?
Why did you get rid of half AT?
Yeah, why did I get rid of a half AT squared? Who can tell
Because
me?
we can add some to the same.
By the same reason previously, we know that these must be the same units if I'm allowed to add them together. So I'm allowed to drop this if I just want to know what the dimension, what the units are. I don't need to look at this part. It's enough just to look at this part. It's a bit like if I have A plus B and A is, say, 5 kilograms, I know that B must be some kilograms as well. Otherwise, I'm not allowed to add them together. So if I only want to know what the units are, I can drop this piece. Yeah. What's U? Speed, that's length over time, and then T is dimension time. So they cancel, and you're left with length. So whatever country you're in, S will be in feet, meters, kilometers, whatever. Okay. Now, I want to give you an example that shows you how useful this is. Can I go down, or do you need to write that down? You need to write it down? Okay. Yep. Okay, so let me give you an example of when this is really useful. I've got one here. Yeah. I'm going to tell you. Now, don't worry. If you don't know this, we're going to do it shortly. But A is acceleration. And I'm going to tell you what the units are, or the dimensions. It's meters per second squared. So that's length per time squared. That's the dimension of A. But don't worry if you didn't know that. I'll just tell you it for this question, okay? And let's suppose I have this formula. A equals, we'll go with K or n v n.
Is it for the circle?
It's for the circle, yeah. What you have here is for a circle. Or is the radius, so that would measure length. And v is the speed, which we know now is length per time.
K is a constant.
And very good, k is just some constant. It has no units. Okay, so here, well, I don't know actually.
Okay,
What is it? It has units, yeah. Let me see what they said here.
You can just find out it if you want it.
Suppose we're told the acceleration of a particle movement uniform speed v in a circle of radius r is proportional to some power of r. Determine the value of n, m, and
it
radius
should
of
be 1 over meter.
Yeah. In fact, you don't even know what, you don't need to know what the units are for k to do this.
No, you need.
Well, for what I want to do, for what the part of the question I want to do. Yes, of course, you will need to know k in the future.
So this is the
Yeah.
formula for acceleration.
No. Don't think of it as any kind of formula. I just want to show you an example of using dimensions when you have formulas. But don't think of this as a formula we'll need to use again. Okay? Just think of it as some formula I made up. And it's about n and m. Okay. The reason for this, I want to show you how this can be very useful for finding parts of formulas which you don't know. We don't know A, we don't know K, we don't know R, we don't know V, we don't know N, and we don't know M. But in fact, we can find N and M here because we know that the dimension of A, whatever A is, acceleration for a circle, formula, whatever, doesn't matter, we know that the dimension of A must be the same as the dimension here. You know, it must match up. If this is length per time squared, then this whole thing must be length per time squared as well. Okay? So that means I can figure out what the n and the m is because I can put this in here and I can put this in here and I can choose what the n and the m must be to keep it balanced. Now it's a little bit tricky, but I'd like people to try this for me. I'd like them to try and figure out what the n and the m must be to keep this balanced. Okay, I'll give you a minute to try it. So tell me what n and m must equal. What number? Yeah?
Square.
Oh yeah, but prove it. Show me, yeah.
So here we have to take k as.
Well, let me see what I do with k. You know what? Will we just get rid of k? I think that'll just make our life easier. Yeah, let's just get rid of k. And if you want,
Oh, I know.
there we go.
N should be equal to -1 and M should be.
Yeah, but did you show it using the technique?
I guess so.
You guess so. All right. Well, I'll do it in a minute. You can see if it matches up. Okay. So yeah.
If n is 2 but m is 1, and in that case then because r equals l, it will be l squared times l over, which m is 1, so it's going to be l over t. Then there's 3 l's, so 2 will cross each other, and then in the end we just have l over t, which will be then a equals l over t.
But we need L over T squared.
Oh,
Yeah. Will we try it now? How many people think they have it? You think you have it, yeah? Including a reasonable proof.
I mean, I don't know.
A probable
It's
proof, yeah.
Yeah.
So what have we got for N?
And
Yeah.
-2.
-2. Ooh. N. Maybe m is minus 2, is it? Or positive 2?
M is positive.
Yeah, one of them is positive 2 and one of them is minus 1.
Yeah.
You got a 2 and a minus 1? Okay, let's have a look at it. So what dimension is A? Length
Over T.
over time squared. And that's to equal this dimension here, which is length power n. And here v, which is length power m over time power m. Can you see that? Because remember, v is speed, which is length over time. Yeah. Okay, now we can do some cleaning up here. On the left, I can say that's L t minus 2. It's the same thing. And on the right, let's see, that's L n plus m, because they go together, t minus m. And it's like there's a 1 here. So if you compare, that must be the same as that, and this one must be the same as this one
So
here.
minus M equals minus 2.
Yeah, so we get minus m equals minus 2. So m must equal 2. That's looking at this one and this one. And then this one and this one. N plus m must equal 1. So that's n plus 2 must equal 1. So n must equal minus 1. So I can go back and I can say now A equals, what was n? I just said it's 1 or, yeah, minus 1. And v, the m is 2. So we get v squared or minus 1. Or another way of saying is v squared over or. If you want to write it back in at the start. I think it's important that you see this because you can sometimes just look at the dimensions to actually get a lot of information from the equation. Okay, so it's useful. And it also is useful for checking if you made a mistake, if you had the right dimensions in your answer. Okay, alright. Now we can talk a bit more about units. Do you need to write that down there? So when you said you did it look like this?
I didn't put minus m equals minus 2 and plus m equals 1.
You did, well, add those two in. They're important. Okay, can I scroll down? Do you have this taken down? Yep. Okay. Now, we will never need to use feet or pounds or anything like this, okay? But we will sometimes need to convert our units. Like, for example, meters to kilometers, hours to seconds, stuff like this. So we're doing this not because we need to convert to feet, but because we need to practice converting, making changes. Okay.
So this is only with powers. Usually it's with powers.
Usually with powers, yeah. Most of the time, that's what we need for our problems, yeah. But anyways, I'll just do a couple of examples here. So, for example, 1 mile equals 1609 meters. Yeah, we'll just use that one for example. So I would like to write, for example, 60, let's say, miles per hour. If this is a physics class, what units do you think I would like to use instead of miles per hour? Meters per second. So I want to know how many meters per second this is. Okay. So let's see how we would do that. So that would be 60 Now let me just write this properly, because miles per hour is like this. Miles, that's the unit, over hour. So we want to change this from miles and hours to meters and seconds. Okay. And if it really helps, you can think of it as 1 mile and 1 hour if you want. Okay, so we know that 1 mile is 1609 meters. And then 1 hour, how many seconds is that? 60 by 60. 3,600 seconds. 60 by 60 minutes and seconds. So if you take out your calculator and do 60 multiply 1609 divided by 3,600, you'll get the answer in meters per second. So what's that? 26.8 meters per second. Okay. I'll give you one to try in the other direction. So I would like you to give me 10 meters per second in miles per hour. So I would like everybody to convert the other direction now, just as a little practice. Does everybody have a calculator now? Who needs to get a calculator still? You need to get one? Yeah. So, what did we get? Yeah. Yeah. How can we roughly check if the answer's right? I don't know, what would be a way to get a rough idea if it's right? Well, my last answer, 50 miles per hour. How many meters per second is that? Well, there it is there, 26.8. Wasn't it 50 miles per hour? Or 60. All right. 60 miles per hour is 26.8 meters per second. Yep. So roughly, if you want to change mile per hour into meters per second, make up a rule. What would be a rough rule? Like a rough rule. Yeah, divide by 2 if you want to go from miles per hour to meters per second. So if you want to go the other way, meters per second to miles per hour, roughly you should multiply by 2. So your answer should be about 20 miles per hour. And what answer did you get? 22, okay? Now it's important that you think about this, because in the exam, when you get an answer, you need to feel like it's the right size of number, okay? So if you've got an answer like 200 or 2,000, you know you've done something wrong, okay? So you need to practice getting a rough idea. You know what I mean by rough idea? Like just a rough, approximate idea, a general idea, okay? Good. So I'll just do this one really quick, but it looks like most people got it. So we have 10 meters per second. That's 10. Now, it's a little bit different because, maybe I'll write it down in blue here, this piece. We know that 1 mile, how many meters was that? 1,609 meters. So that means 1 over 1609 mile equals 1 meter. Yeah, it's just like what we do in maths class. So here will be 1 over 1609 mile. And second, we know that 3,600 seconds equals 1 hour. So then 1 second would be 1 over 3,600 of an hour. Yeah? Let me write it here. What I'm doing is saying 1 second equals 1 over 3,600 hours. In other words, 1 second is 1/3,600th of a second, of an hour. Yeah? Is that okay?
Yeah.
Yes? I don't know. It's hard to know when people are confused or if that's just their normal face. It'll take me a few days to get used to it, okay? So here I need to type in 10 multiply 1 over 1609 over 1 over 3600. So what do we get for that? This will be miles per hour. 22.4 miles per hour. Okay. Next now. Can I go down yet? Okay. Now this will be very important for the exam, or for physics. SF for short. Yeah? We know what this is?
Yeah.
Yeah, so tell me, what is significant figures?
The total amount of numbers in the...
Yeah, it's like how many digits
how many
are in your
digits,
answer.
yeah.
So let me just give you, we'll do this in maths class too, but just to give you a quick idea. 4.32, that's 3 significant figures. 2.3, that's 2 significant figures. 5, that's 1 significant figure. As an example, I'll do some more, okay? As you said, it's like counting the digits. Yeah, the zeros are the ones that sometimes cause trouble. So, where's my pen there? 0.00213. How many significant figures do we think? 7 maybe? 4 maybe?
4 or 5.
Yeah, see, it's a little bit tricky. It's actually 4. And the reason is, you don't count the zeros at the start. You don't count them. Okay? Now, be careful. If I did this, how many is that?
4.
It's still 4. Because I said don't count the zeros at the start. But you still count the zeros in the middle. Okay, so be careful with that.
You don't need to count if they are in the end.
Or at the end, yeah. So, like, I mean, if I had 0.002134000, that's really the same thing as that. So it's still 4. What about this? 500. 3. Yeah. 500.00. Still 3. Okay. One more. 501.01. 5. Okay. So what do we need to use? I think in the exam they tell you you use 4 significant figures. Okay, so that's what we need for the exam.
So if they do not specify,
Oh no, it says it on the cover of the exam on the front page.
Some questions may ask for more or less, right?
No, actually, they don't.
So always on
The question never specifies.
So if you get like, I don't know,
Yeah.
500,000.
500,000?
Yeah, 500,000.
Mm-hmm.
Yeah.
500,000, hang on. Yes.
So you need to include only 4. So you have to write 5,000.
Yeah, well,
Or you have to write 5 times 10 to the power of 1.
that's what I was saying. We need to use scientific notation, which is something that I want to do later.
Times
Yeah.
by 10 to the power.
Yes, yes. If this was in the exam, they would want it with a 10 and a to the power. Now, that's something you'll do in chemistry as well, okay? And I should also say, it's 4 significant figures, but that's only for the calculation. But the final answer at the end of the question, that's actually 3.
Okay.
Now, I'll double check that. It says it on the exam, okay? But the answer is always 1 less than the calculation. So in your example, you would want to write it as 5.00 by 10 to the power of 5. Okay?
If you write just 5 times 10 to the power of 5.
Oh yeah, that's fine, full marks. And in fact, if you wrote this, I'd still give you full marks. Okay? But what's nice about your calculator, the Casio one I told you,
Yeah.
there's a button that converts it into this form on the Casio calculator. Do you know what button that is?
Yeah,
See,
SD.
this might not have it.
No, otherwise.
Oh, it does, yeah.
SD.
No. Not that button. Let's type something in. ENG button. Did you see you have ENG button? Yeah, it changes it into a power form.
Which one?
ENG. It doesn't always do it.
Yeah, it does.
Oh, it did. Okay. I'm sure there's some option to change how many decimal places you want
Yeah.
in the menu, but that's how you can convert it into that form. Have you used this in chemistry?
No.
No.
In chemistry we don't really count anything. So.
Well, you have to do some counting in chemistry, you know, moles, all that stuff.
Now it's just electrons.
Okay. What else was I saying? No, I think really that just for the first section, that's all really. Like I said, this course is, I'll just go back up to the top here. This course is broken up into 6 parts. So this would be part 1 of 6. Yeah. Semester 1, yeah. So, 6 parts in total, okay? I'm not going to go too fast in the first week because I don't know how much physics knowledge people have from high school, okay? But I'll give you some time to practice some of these. Let me just go down here. Now, those people who have the book, if you don't have the book, that's okay. I'll put it up on the screen now. Well, okay, just before you start the questions, I just want to give you one formula in case it's in one of the questions. Or will I leave it? No, I'll leave it. It's okay. Okay, so can you go to page, let me see. Page 16. Yeah. 16. Yeah, see that page 16 and 17. Now, if you don't have it, let me put up on the screen here. (16 and 17). Let's see. Oh, actually, I know. Mechanics. I want you to try some of these, but let's see which ones. You probably need that a little bit bigger. Can you see that?
Yeah.
Yeah. Now you don't. Well, you have the whole book. The answers are actually at the very back of the book. Let's see. Yes, yeah. But what you'll notice is you only get the answers to the odd questions. Do you know what that word means, odd?
Yeah.
What numbers are odd?
One.
1, 3, 5, and so on. So I would only like you to do the odd questions because you can't check the answers for the even questions. So just for a few minutes, I want you to do some of these conversion of units and just do the odd ones. So 13, 15, 17. Yeah, just do those 3 first. Let's see how you get on with those. Get. Okay, so the first one, 13, it's 75 feet multiply 125 feet. That's the area. Okay, so we need to change feet into meters. I think I had it up on a moment ago. How big is 1 foot? What did we say? 0.3048. Thank you. Multiply 125, and then this is now the same, 0.3048 meters. So we have 75 multiply 0.3048 multiply 125 multiply 0.3048, and then you have a meter here and a meter here, so it's meter squared. Okay, so what's this, please, on your calculator? 86870.96. Okay. Now, just to practice, if I want 3 significant figures, what would this answer be? 871 meters squared. Okay, we're happy with that. I think everybody got this though. So we'll go on to the next one, 15. A solid piece of lead has mass 23.94 grams and volume 2.1 centimeters cubed. Now this is the formula I was saying, oh, will I give it to you or not? And I didn't give it to you. But I want to see who knows it. It's the formula for density. Isn't that what they're looking for? You kind of have it in the question because they give you the units of the answer.
Kilograms per cubic meter.
Yeah, so as a formula, what would that be?
Mass over the volume.
Yeah, mass over the volume, yeah. Now, if I keep the units the same, what units would this be? It'd be gram per centimeter cubed. But they don't want this. They want kilograms per meter cubed, isn't it? Yeah, so let's do it bit by bit. 23.94 grams over 2.1 centimeters cubed. Okay. Now, how big is 1 gram compared to 1 kilogram?
Times 10 to the power minus 2.
Yeah, 1,000 grams equals 1 kilogram. So 1 gram equals 1 over 1,000 kilograms. 1 gram is 1,000 of a kilogram. And now, centimeter. So how big is a centimeter compared to a meter? Yeah, it's 100th of a meter cubed. So we get 23.94 multiply 1 over 1,000 all over 2.1 multiply 1 over 100 cubed kilograms per meter cubed. Did anyone type that in? What do we get?
11.4 times
11.4.
times 10 to the power.
Oh, good, you gave it to me like this. Kilograms per meter cubed. And by the way, you can write it like this as well. Okay. And that's 3 significant figures. Good job. Okay, 17 now.
We need to measure the paper.
Do you?
That's the only way to do
A
it.
student's dormitory room measures 3.
We need to know the area of one.
Alright, okay. We can estimate it. Unless somebody has a ruler. Does anyone actually have a ruler? No one has a ruler? No? No one has a ruler? No one can measure this? Yeah, even a small one will do. Actually, I think that's A4 size. A4 is 297 millimeters by... I forget. Does anyone know A4 size? 297? No, okay. We can measure it then. Yeah,
So we have to measure we have to measure this one.
we do. Well, look, she's going to measure for us. Thank you. Yeah?
Why did we write m to the power minus 2?
It means the same thing. When you divide by meter cube, it's the same as m minus 3. The minus 3 means it's divide.
I wrote m cubed without the minus, is it wrong?
On the top or on the bottom?
No, on the bottom. Final
Oh yeah,
answer.
that's fine. Oh yeah, both are fine. Yeah. I did that because I ran out of space. That's all. 21. So it's 297 millimeters by 210 millimeters, I guess.
Oh,
What would they expect us to do?
No. This is a bit back.
210
Oh, it says it on your book.
yeah.
Oh, that's great.
21 centimeter
Where?
times
Where?
29.7.
Yes, 21 and yes, okay.
29.7.
All right, so we got the area of the book.
And how many sheets are there?
Well, let's see. This one here, 29 points, so 0.297 of a meter. Yes, and then this one here is 0.21 meters. Can you multiply these and tell me the area, please? Point zero 227 237 meters squared. Okay. What I'm going to do,
We need to count the pages.
well, before I do that, I want to know what the area of the room is. So, here's his room. And it says it is 3 by 8 by 3 by 6 and 2.5 high. So it's 3.8 here, 3.6 here, and then the height is...
We don't need the height.
well, you see,
We don't need the.
what he wants to do, so read it. We do need the height. No, I think we do need the height, yeah.
We need
We need the height, and we need, I think we need all these 3 numbers. So, if he wants to put up wallpaper, if he wants to put his book up on the wall, he needs to put it on how many squares, or how many shapes?
4.
It's 4 in total. Well, we won't count the top and the bottom. So 1, 2, 3, 4. Okay, so the first square here, that is 3.8 multiply
By
2.5. That's for this one. Then this one here,
2.5 times
yeah.
3.6.
and then the one at the back is the same as the one at the front, yeah. And the one at the side is the same as the one I just did. So a quick way to do it would be just to multiply this answer by 2. So what do we get here?
37.
Exactly, yeah?
Yeah.
Yeah, 37
Meters.
meters squared. So if he wants to do this, how many pages does he need? He would need 37 divided by
Can you go?
the previous answer, 0.06237.
You'll need 593 pages.
Now, is it 593 point anything?
0.23.
So he would need 594, and then he has to cut the last page. Is this possible? No, because I think the entire book is not even 594 pages. So it doesn't. Well, if we just use my book, it's only 100 pages, so it's not possible then. I know this seems like kind of a silly example, but it's important because, you know, later in the course we'll be doing problems where, you need to make a metal tank, and the metal tank, you need to work out how big each side is, and you have to work out how thick it is, you have to work out how much metal you have, and then maybe you melt the metal. You know, I know it seems a little bit silly, but it actually is important for when we do the materials, you know, heat, metal, elasticity, all this type of stuff. Okay? Now, I want to do some questions for you from 27, 28, those four there, 27, 28, 29, 30. But just before I go on to that, I want to give you a little bit of vocabulary, okay?
Can we break up in the vocabulary?
Well, what I am thinking is I'll just finish a little bit early.
Alright.
So we'll finish in half an hour then, about, okay? I just want to give you some words here. One word. So, density, we just did. What was it? It was mass divided by volume. But what's volume in terms of mass, length, and time?
Length.
Length
Cubed.
cubed. Okay. What's speed? What do we say speed was? Yeah, so it's a
Length
dimension.
over time.
Length over time. Okay. What's area?
That's length squared.
Length squared. Okay, so that's like area, for example. That's speed. That's density. Does anyone actually know the symbol for density?
D is in the Greek letter.
This Greek letter, yeah.
Right.
What did I say? This was speed. And then this one here, what did I say? Is area as an example, okay? The reason I'm showing you this is I want to give you a word here. This one here is called a rate.
Yeah.
Whenever there's a time in the denominator, we call that a rate, okay? So this would be a rate. I'm trying to think of another one that has it. Velocity is the obvious one. What else has it? Well, I suppose actually if you think of a balloon, balloons getting bigger or smaller. Acceleration too. I'm just trying to think of ones that have only t, not t squared. Think of a balloon getting bigger or smaller. So its volume is length cubed over time. What I mean by that is how big the balloon is getting. So for example, if I wrote down 1 meter cubed per second, what do you think that would mean for the balloon? What do you think that would mean? Yeah. Every 1 second, how much bigger does the balloon get? 1 meter cubed bigger. Okay, that might actually be, we might want to make that a bit smaller. 0.01. Okay? That is called a rate. So this word rate, it means whatever you have here is over time. Okay? That's what a rate is. That's important. You'll see that word a lot. So write that down, please. And now I'm going to do some questions from 27, 8, 9, and 30.
27.
Yeah, some from that section. Okay. Can I go down? You have that word? Rate? Yep. Okay. Now. Fermi.
27, we need to know what is typical size room.
For which one?
27.
Ah, yeah, well, that's related a little bit to what I'm about to do. Or another name for this piece I'm going to do.
Order of magnitude.
Mm-hmm.
Is the first one from Latin? Came from Latin. First word.
No, actually. Does anyone know this word Fermi?
Is it somehow related to, indirectly related to the Fermi paradox?
It is. Well, yes, as in it's a person. Yeah. So Fermi was a physicist, but the reason he gets his name after this is because Fermi was very good at approximating. Yeah. Well, he was good at many things, but he was surprisingly good at approximating. So what I mean by approximating is that you just want to get a rough idea, okay? So the example that's here in the book is how many tennis balls will fit into this room? Okay. Lots, but we would like a number, okay? So it's fine, you just need to estimate it, and you just need to make sensible guesses. So if I want, for example, in number 27, how many tennis balls, or actually tennis or table tennis? Oh, table tennis, that's different. Table tennis balls. Okay. Ping pong balls, you know, these small ones. So, what formula would I use to do that? What would I need to know if I want to know how many balls will fit in this room?
Volume of the room.
The volume of the room and the volume of the ball. And what do I do with these two numbers?
Compare.
Divide them. So the volume of the room divided by the volume of the ball. Okay. Now I don't know how big a room is, but if we take this room as an example, this room, we just need to roughly estimate it. Okay, so how many meters this way do you think?
3, 4, 6.
3. 1. I know. I think we can do better than that.
3 and
Or maybe even 6. No, let's say 5. 5. Okay. And what about this way?
10.
No, I don't think it's quite 10, because 10 would mean it's twice as big.
Okay.
7 or 8, yeah? So we'll say 7?
8.
8, alright, okay. 5, 8, and then the height? Yeah.
Same.
5, 8, 4, okay? So it's 5
1, 6.
by 8 by 4.
1, 6.
Yeah. But before we do the calculations, we need the volume of a ball. Now, does anyone know the formula for this? The volume of a ball? A sphere?
2 pi.
No. 4 over 3
Oh.
pi
R squared. Cube.
r cubed.
Cube, correct.
Now listen. Hey, listen carefully. This is how what I was teaching you in the first class is useful, because if you forgot if it's squared or cubed, you can check. What's the dimension of volume?
Meters per second.
No. Relax.
Dimension.
Think. Dimension.
Length of the
No, volume.
volume. The length.
No, fuck. Hang on. Wait. Stop. Wait. Brain isn't working right now. It's before lunch, I know. Just relax. Just think carefully. Volume is what dimension? Length cubed. Okay, good. So here I have length cubed. This here, no dimension. So, if you weren't sure if I should use r squared or r cubed, you know it should be r cubed, because what's the dimension of r cubed? What's the dimension of r? Length. So it'd be length cubed. Okay? So that's what I'm saying. You can help check your work. If it's square or cube, you can see it must be cubed. Okay? Anyways, back here. Oh, where's it gone? Ah, here. So that will be 4 over 3 pi or cube. Now I need a number for or. So ping pong ball. How?
1 centimeter.
No, I think in total maybe 6 centimeters.
So it's 2 of
So it'll be 3 for the radius. Okay. 0.03. What's the number here? Cubed. Now, I'm not going to use the calculator, okay? Because part of the thing about a Fermi approximation is you're supposed to do it in your head. Okay? So, 5. If I want to write this as a power 10, what power would that be? It'd be close 10 power 1. Okay? 8, that would be a 10 as well, wouldn't it? A 4, what would that be? It would go down to 1. It rounds down to 1. If it's not clear what I'm doing here...
Actually, 4s are just going out.
No, I want to write my numbers all like this.
Okay.
You know,
Okay.
so that would be 584. Okay. 4 over 3
1.
would just be like a 1. Pi is 3.14.
No, it's zero.
Oh, sorry. Yes, 0, of course. Pi is 3.14.
0.
So that'd be a 0, wouldn't it? Now, this is like 0.01. So what's that? It's 10 to the minus 2. You have 2 zeros. And then this is cubed. Okay? So add the powers. 110, 2. This is minus 6. Now don't worry, we have a maths class about powers, but this is minus 6. 0, 0, minus 6. 2 minus minus 6. And you can type this in on your calculator, it'll be 8, yeah. So see, this is the idea. This is called an order of magnitude. This is called a Fermi approximation. So you say about 10 to the 8. Okay? So it's roughly something like this. Now I'm very curious actually what they have at the back. Oh, I don't have the full book. Let's see what we got.
You have 10 to the 6.
Oh well, I guess.
But it's different room. It's 4 by 4 by 3.
Did they use the same room?
No, different. 4 by 4 by 3.
Hang on. 27. Oh yeah, they used a 4 by 4. Yeah, so we used a kind of classroom. They probably just used like a bedroom or something. Yeah. Okay, so you can see that's just what's called a order of magnitude. Okay, that's important. Hey, listen. If you say order of magnitude, that means you only want your answer to look like this. 10 with a power. Okay. Just let me go back. Okay. The reason that this is important in physics is because it's important to check if your answer you got is close to the answer you would guess. Okay? So if we did this properly and we got an answer like 5 times 10 to the 8, then that's fine, because we know the answer should be something like a 10 to the 8. Okay? It's just to give us an idea. Can you mark these questions or write these numbers down? So if you have the book, well, maybe just write it down on the page. So the numbers I'd like you to do, you can do them now. We have 13, 15, 17, and 27. So 19, 21, 23, 25, 29, 31, 33. So I'll say it again. 19, 21, 23, 25, 29, 31, 33. And that's not everything because there's more on the next page, but I think that'll be enough for the first one. So I'll let you start them now. You might even get them finished before the end of the class, and then you have nothing to do for the next class. So there's 15 minutes left. Try to get them done, and then you're free from homework, and then you can take a break then, okay? So you can work together on those, and I can put the questions up on the board. Yeah?
If we didn't finish it now,
Then you finish it at home, yeah.
like as a homework.
As a homework, yeah. So whatever is left to do, that's your homework. Page 6.
The powers.
Yeah. Two things to say really quick. We won't actually do this really until semester 2.
Yeah, just with my
But because it's mentioned, I just want to make sure you have the formula. This is the formula for density. I won't mention it, but I'm sure it will come up maybe in chemistry too, okay? So if you need to know what does this word mean, density means this, mass divided by volume. But that's not really until semester 2. But it's in this, so I need to tell you the word if you see it in a question. Now if you look at the top of page 6 actually, I didn't do this table with you. Some of the words you know, like kilo, mega, giga, tera, peta, you'll know those from computer external hard drives, okay? And then everybody knows centimeter, millimeter, and so on. Micro and nano are two which you might not know, but it's important for physics. Micro -6 and nano -9. You don't need to know all of them. For physics, we really need to know nano. You see nano? Nano
I think
to
from
giga.
I think, yeah, from -9 to 9.
Yeah, 9 to 9, yeah. But I think people also know tera, like 1 terabyte. I didn't do this because you are going to do this in ESAP. Okay? So the lesson you have this week on ESAP is to practice learning those words and how big they are. Okay? So you will do that in ESAP. So I'm warning you now. Okay? I don't expect you to remember all of them, but if you can remember all of them, that's great. Okay? But the minimum is 9 to 9. -9 to +9. Okay? You need to know those for the exam. They won't tell you in the exam how big a giga is or how big a micro is. They'll expect the student knows that word. Okay? So I'm telling you that now. -9 to 9 minimum. Okay, so have those questions finished then for next week. I will try to print out how many more books? 5 more books? So if you want to get your book, I'll try to print it. If you can come to the teacher's room at 4 o'clock. Are you free at 4 o'clock?
Today?
Yeah. Does everybody have class at 4 o'clock?
So we can take a
Group 1 have, but Group 2 don't. Are Group 2 free at 4 o'clock?
today.
Yes? Because if Group 1 is busy, you should give your book to Group 1, and then Group 2 can come to my office at 4 o'clock to
I
get
think
the book.
everyone today is
Everybody?
free at 4.
Everybody's free at 4?
Today we have classes on 9 till 2.
Yeah.
But mine is different.
There's 2 groups.
Yeah,
So-
I wrote like I finished now. Like I finished at 5. I have.
Are you in the same group as them?
Yeah.
Yeah.
Okay.
Yeah.
So you make sure you get a book, and yeah, you two get a book. Anybody else? So you are free or not free at 4 o'clock? Not free. So you're free. Yeah. Anyone else? Okay. Oh, just the next physics class, which is when's the next class? Wednesday, Thursday? I don't know. Whenever the next class is. Oh no. You're group two. You are free.
Yeah, but what if I had something else?
Like what? Give me something good.
I'm saying if just in the worst case scenario.
Oh, in the worst case scenario, then come see me in the morning tomorrow. Yeah, and then maybe you can do it during the day then. Yeah, I'm in at 9 o'clock every day.
Right, thank you.
Well, a little before 9. So.